Welcome to this explainer. So, today we're looking at something you probably walk or drive over every single day without a second thought. But right beneath our streets, under the pavement and those heavy manhole covers, there is some serious high-stakes physics at play. We're diving into the hidden dangers of everyday infrastructure. Specifically, we're looking at a critical tool used by maintenance crews all over the world: inflatable pipe plugs. Get ready, because we are about to uncover how a seemingly simple piece of equipment holds incredible power and incredible risk.
Okay, let's dive into this. A simple rubber plug sounds completely harmless, right? Kind of like a heavy-duty balloon or a pool float. But the source material describes it as, and I quote, a high-speed projectile capable of causing severe injuries, fatalities, and extensive property damage. Wow, that completely shatters the illusion, doesn't it? We're definitely not dealing with just a simple piece of rubber here. We are talking about serious, explosive forces hiding right under our feet.
Section 1. An unseen underground danger. The vital role of pipe plugs. Now, before we get into the danger itself, we really need to understand what exactly this mundane tool is and why it's so absolutely critical for maintaining the infrastructure that keeps our cities running. An inflatable pipe plug is basically a heavy-duty, temporary device designed to block, isolate, or test sections of piping. Crews use them everywhere: for sewer repairs, routine utility maintenance, testing pipelines, bypass pumping, line isolation, leak testing, you name it. Basically, anytime they need to safely stop a massive flow of water or wastewater to work on a pipe, they rely on one of these plugs to act as a temporary, watertight dam.
And this brilliantly illustrates the exact mechanical process of how a plug expands and seals. It's actually pretty ingenious. First, the crew inserts a completely deflated plug into the pipe. Then, they introduce compressed air through a specialized inflation hose. As it fills up, that thick rubber body expands to firmly grip the interior walls of the pipe. Finally, friction creates this massive holding force, and the internal air pressure seals it tight against whatever pressure is trying to push past. It's a really elegant solution, but, as you'll see, it relies entirely on air pressure.
Section 2. The threat of stored energy. The bomb in the sewer.
The moment compressed air enters the equation, well, the environment changes from a routine maintenance job into a highly hazardous situation. Let's define exactly what we mean by stored energy. It's the tremendous amount of force created by compressed air. Here's the crucial physics difference. Unlike water pressure, which loses its force almost immediately if a pipe breaks, compressed air expands rapidly and violently when it's suddenly released. Even if a plug is inflated to just a few pounds per square inch, that stored energy can turn a slipped plug into a deadly, high-speed projectile in a fraction of a second. It's basically a loaded spring, just waiting to snap.
To manage this incredible force, every single plug has two critical, distinct ratings established by the manufacturer. First is inflation pressure. That's the air pressure actively placed inside the plug to blow it up. The second is maximum back pressure, and that's the amount of water or sewer pressure pushing against the outside of the inflated plug that it can safely hold back. The absolute golden rule here: neither of these specific values can ever be exceeded.
Section 3. Anatomy of a near miss. When routine turns life-threatening.
I want you to imagine yourself for a second standing at the bottom of a dark, cramped manhole. You're in a confined space, relying entirely on a single piece of inflated rubber to hold back literally tons of water. Let's look at a real-world case study from our source material where this exact scenario went incredibly wrong. First, a crew installed a plug in a sewer main, standard procedure. But inadvertently, the plug was overinflated, pushed way beyond those strict manufacturer specs we just talked about. Then, and here's where the suspense really builds, an employee actually climbs down and enters the confined space of that manhole. They're standing directly in the firing line when the excessive internal pressure causes the rubber plug to fail completely. It blows out of the pipe with a sudden, violent explosion while the worker is still trapped right there in the hole.
Now, what's really interesting about this slide is how it breaks down what went wrong. This wasn't some freak act of nature. It was actually a compounding series of small, entirely avoidable human errors. The crew didn't use a calibrated pressure gauge, they just blindly relied on the compressor's general settings. Basic installation procedures weren't consistently followed. The initial job hazard analysis completely ignored the stored energy risks of compressed air. And to top it all off, nobody in a supervisory role actually verified the setup before that employee was sent down into the confined space.
Miraculously, no injuries actually occurred in this specific case. But the core lesson remains: a sudden, violent failure can happen in an instant. You have to treat inflatable plugs as energized equipment. This incident proves beyond a shadow of a doubt how incredibly fast a mundane maintenance task can turn fatal if this equipment is overinflated or misused in any way.
Section 4. Rules for Survival. Containing the hazard.
All right, we've seen the disaster scenario. Now let's pivot to the strict safety protocols and practical solutions that empower workers to survive these highly hazardous underground environments. Proper installation is absolutely everything, and the margin for error is essentially zero. Just look at all the things that can go wrong if a worker isn't hypervigilant. The plug isn't centered, it rests partially outside the pipe, debris prevents a flush seal, the insertion depth is wrong, the inflation hose gets bent, or the rubber gets twisted during insertion. Yeah, it's a long list, but it's meant to show you that any single one of these common errors massively increases the risk of a catastrophic blowout.
And then, of course, there's the equipment itself. When evaluating the gear before a job, inspectors look at three main areas. For the body of the plug, they're checking for cuts, cracks, bulges, or dry rot. For the hardware, they hunt for missing fittings, worn threads, or loose connections. And the air system, it has to be absolutely flawless. No damaged hoses, no defective regulators, and definitely no inaccurate pressure gauges. If any of these signs of compromised gear are found, that equipment must be removed from service immediately, no exceptions. Let's move to and see how this builds into a foolproof safety sequence. These are the exact, non-negotiable safe work practices required for every single installation. 1. Read the manufacturer instructions and verify plug size. 2. Inspect the gear and use only calibrated gauges. 3. Inflate slowly and monitor the pressure continuously. 4. Establish an exclusion zone to keep all personnel out of the line of fire. And 5. Rigorously verify that pressure before anyone is allowed to step foot inside that manhole. Section 5. The power to stop. The ultimate failsafe.
Even with all those checklists, things can still feel wrong on the ground. That brings us to the final and frankly most crucial layer of safety: stop work authority. So the crucial point is that every single employee has the power to halt operations. Work must stop immediately if the pressure can't be verified, if equipment is damaged, or if manufacturer info is unavailable. If the plug begins to shift or move even slightly, you stop. If pressure exceeds specs, if unsafe conditions suddenly develop, or if you're just missing supervisor approval, you stop the job.
And this is backed up by a definitive corporate rule. No employee will be disciplined for stopping work due to a legitimate safety concern. That is a powerful guarantee. It proves that human safety always takes absolute priority over just getting the job done quickly. You are completely empowered to protect yourself and your crew.
Which brings us to the end of our explainer on the hidden dangers beneath our streets. We've seen the physics, the strict rules, and the massive stakes involved in something as simple as an inflatable pipe plug. So, I'll leave you with this final provocative thought. If you were standing at the edge of that manhole and you saw a plug just begin to move, would you have the courage to stop the job?